started. But, the big thing here is I actually think this section is easier because you don't have to do 4 plus 5 is 9, where you could make a mistake. Instead, you just leave it as w plus h, done. I don't need to simplify that. I can't simplify that anymore. So I actually think it's easier. You just say, I'm multiplying by w, and I'm done. Right? Whereas with numbers, you have to actually figure out what 3 squared plus 1 minus 7 and actually simplify it down. So, here we go. Okay, for example, 2.4, formulas and percent. I'm barely going to write anything on this. I'm just going to do some examples with you because, as I said, there's no new information here. It's just being able to stretch your mind and see an analogy between problems we just did and problems with letters. So, here's number 2. D equals RT. Solve for T. Alright? So I'm just going to give you the one sentence of notes and then we'll actually solve the problem. So the big idea here. So in other words, if I'm solving for t, I'll think of t as my x, and I'll think of every other letter as a number. Okay, so I envision this problem as any number, let's say d, I think of 8 when I think of d, I don't know why, equals r, that's more like 3, and then t will be my x. And that's the problem that we're asked to solve. Right? How would we solve 3x equals 8? Divide by 3. That's it. So how would we solve d equals rt for t? Yeah. Divide not rt, divide by r. Right? So that's the way to think about it. It's exactly the same steps we just did. The only difference are letters instead of numbers. No new tricks. No new steps, no new logic. So over here, we'll do a couple examples. Okay, and you can literally write this on a test next to a problem. Just write it where everything's a number except for the original. So here we'll solve 2 together. So d equals RT for t. So this is like 8 equals 3t. I'll just change the other ones and leave the t. So we're going to divide by r on both sides. This r cancels and we get t equals d over r. Boom! We solved for t, and that was because over here we divided both sides by 3 and we saw t equals 8/3. Right? That analogy helps a lot of people. So let's do number 12. Number 12 is P equals C plus MC. Solve for M. So what I'm going to do is I'm going to go over here and say, this is like, P is a 7 equals, I'll write it all in black. Okay, so 7 equals, I don't know, let's say C is a 6 plus 6M. Okay? Or you can write X if you want to write M as X, if that's easier for you. Okay, so how would I solve this for M? Well, in this problem first, and then we'll jump back to that one. What would we do first? Yeah, we'd subtract the 6 first. Subtract the 6 first, and we get, cancel, we get 6m equals 1, and then what would we do next? that? We divide by 6, divide by 6. Doesn't matter if it works out nicely, we're just making numbers up, so it probably won't work out nicely. So back over here, last time we subtracted 6, what are we gonna do? Yeah, we're gonna subtract the c. We want to get m by itself, so first we need to get all the other terms that don't have an m to the other side. So we're gonna go, okay, let's subtract the c, that cancels, and we have mc, and again, the nice thing is, what's p minus c? Just p minus c. There's no simplifying, there's no combining, we're done. There's no arithmetic to be done, you just write p minus c. Last step. Yeah, we want to get m by itself, so we divide by anything that's multiplied by m. So we divide by c, and guess what? What's this whole side divided by c? That's it. No simplifying to be done. We just say, okay, that's m equals, and we just leave it as p minus c over c. Done. So I think it's easier because we do those same steps, but we don't have to actually combine p and c or divide by c. The hard part is that analogy. Seeing that this problem and this problem are exactly analogous. You'll follow exactly the same steps for exactly the same reasons, because what you're solving for is m in both cases, regardless of whether it's letters or numbers, whatever. You have something multiplied by m, something added to that term equals something. So you follow the same steps to isolate the m regardless of numbers or letters. And I know it looks scarier, and you can get that test anxiety and blank out and say, oh my gosh, there's W's and F's, and I like that the book uses real formulas. I mean, the first one was distance, rate, and time. I don't remember what number 12 is. It has, I think, a note next to it saying what it's from. Oh, no, it doesn't right now. But they're real formulas. Okay? It even says, do you recognize the formulas? If so, what does it describe? I don't know what P equals C plus MC is. Anybody recognize that from science, physics? Okay, that's an interesting one. Let's do 16. Okay, 16 is A M on line M equals A over 740. Solve it for A. So, really quickly off to the side, I could say that's like 10 equals A over 740. So if we want to solve for A, what would we solve? How would we solve?
Multiply by 740.
Yeah, it says A divided by 740. We did that inverse operation we were talking about yesterday. And that's it. One step. So over here, we multiply by that thing on the bottom. So we get A equals, and again, we don't need to combine 740 and M. We just leave it as 740 times M. Okay, let's go to the later problems, because there is one thing that we haven't really done yet that comes up in, I believe, exactly 2 problems. But you don't even need to use it, you can avoid it. Let's do, oh yeah, you don't even need to use it. Okay, never mind. So let's do problem 24. This is one of the harder ones in the section. So 24 is A equals 1/2 H, A plus B. Solve for A. So an analogous problem over here would be 10 equals 1/2 times 6 times, and this is A plus 5. Alright, so what would we do first with that problem? I think it's 2.3. How would we solve that problem first? You actually have 2 really good choices here. So.
Distribute.
Yeah. Right, we get rid of parentheses first. So first, we distribute this in to get rid of our parentheses, so we'd have 10 equals 1/2 times 6, let's just write that as 3. So that's 3a plus 15, okay? So over here, we won't be able to simplify, but whatever, we'll still write it. So this is a equals 1/2 HA plus 1/2 HB. Look, we don't have to do anything with fractions or numbers, there's no simplifying to be done. Great. So, what do we do over here?
Subtract 15.
Yeah, we subtract the thing that doesn't have any a's, because we want to get a by itself. So our first rule is put all the a's on one side and put all the other junk on the other side. So over here, we're gonna subtract 15, subtract 15. So this gives you 3a equals -5. So over here, subtract whatever this term is, who cares what it is. And look, big A minus this doesn't combine, so we're done with that. So, 1/2 HA equals A minus 1/2 HB. And then the last step over here is, yeah, divide by 3. Divide by 3. Okay, so A equals -5/3. Over here, what will we divide by? Yeah, just whatever's next to A, it doesn't matter what it is. Divide by 1/2 H, divide by 1/2 H, and A equals A minus 1/2 HB over 1/2 H. Now you could simplify this. I would recommend not doing it right now, that's not the focus, that's not what we're focused on right now. If you're comfortable with it, great, simplify, that's awesome. I'll not grade you down right now if it's not simplified. Okay? If you ever answer a, fraction question and you've not reduced the fraction of numbers, I will penalize you, a point or half a point or something. However, when we're talking about letters and variables, we haven't gotten to that point yet, so I want you to solve. Once you've got A equals, stop. Regardless of what it looks like, that's done. Okay? So it's the exact same steps as if you treated everything other than A as a number. You follow the exact same process as 2.3. The only difference is it looks scary, but the exact same steps, okay? If you just double check, that's all the problems, so let's just go really quick. So 2.4, just 1 to 25 log. Yeah, that's it. Okay, so that's 2.5. Again, 0 new things. And the big hint I gave you, which isn't written here anymore, is if you're solving for A, think of everything else as a number, and you can even write the analogous problem right next to it and go step by step down. Okay, that's one of those just good habits, it's helpful. If you use it, awesome. If you hate it, awesome. Okay. So work on that, and then we'll do our last section in about maybe 20 minutes or so. We'll do 2.5 today, and then the homework for Monday will be 1.8 to 2.5.